Hi guys, let's talk about rocks, okay? So there's basically only three types of rocks. Um Igneous, metamorphic, and sedimentary rock. And all of these rocks can become the other type of rock as long as they go through a certain type of process, right? A certain kind of change to make them the other type of rock. Okay, so that's what we're going to talk about. So here's kind of the same thing that's happening, but it's actually showing it within like the actual crust, which is pretty cool, right? So we have igneous rocks that are going to have to melt and then cool, right? So we have magma here that is erupting and stuff, and so we can have igneous rock here. We can have it erupting but not really coming to the surface. That would also be intrusive igneous rock. Metamorphic rock, notice how it's down here because it's just experiencing a lot of pressure, but it's not totally melting, okay? And then sedimentary rock, you can see that it's kind of like a little above that. It's not experiencing as much pressure to where there's heat. It's just basically pressure. So in order to make sedimentary rock, I just kind of have to squeeze it a little bit. Metamorphic rock gets squeezed a lot to the point where it gets hot. And then igneous rock gets so hot that it melts and then cools, and that's what makes igneous rock. So here are some vocabulary words. Weathering breaks it, right? The breakdown of rock. Erosion takes it. It's the movement of rock and sediments. And then deposition is the dropping off of these sediments or the rock, right? So weathering breaks it, erosion takes it, deposition makes it. And makes it in that it's like making a sand dune or it's making a river delta, right? So that's an easy way to remember it. Weathering breaks it, erosion takes it, and deposition makes it. Think of deposition as kind of like your parents making a deposit at the bank, right? They're dropping off money at the bank. Compression is when things are squeezed together, right? Compressed, pressed together. Cementation is gluing together. Think of like cement, right? When you look at cement, it looks like glued together rock, right? So that's cementation is gluing together. Crystallization is when things cool, right? When magma cools. Melting, you should know what melting is, right? And then heat and pressure is compression and squeezing. It's squeezed so much that it gets hot. Here are the three types of rock. So you're going to need to pause this to copy it down, but let's talk about each of these. Sedimentary, right, is going to be when you have sediments that get squished together to make a rock. So we start with a rock, right, that gets weathered and broken down into sediment, and then those get deposited somewhere, and over pressure, right, in time, they get squished together and basically cemented together, right, and become a sedimentary rock. And usually you can identify these by layers, that you can see layers in them. And I'm going to have examples of this in class that you can look at, okay? Then we have metamorphic rock. So metamorphic rock is going to be rock that gets buried, and it's going to either be buried deeply enough to where it's got a lot of pressure, it actually gets hot, or it could be near some sort of volcanic activity where it gets a little bit of heat but not melted. It's not going to totally melt. It's just going to kind of meld together and get kind of pressed together, but does not turn into a liquid. Igneous is totally liquid. It's like lava, right? Or magma that cools and becomes rock. Okay, so that's igneous rock. So rocks are made of minerals. Um, Basically, it's like the ingredients of rocks, right? They're inorganic solids with a fairly constant chemical composition. So you probably have heard of like quartz or chalk. All of those are minerals. We are talking about tectonic plates also, right? This has to do with tectonic plates and the pushing under of the plates. And so this is where we can also have metamorphic rocks forming because of all that heat and pressure squishing things together. Okay, so let's talk about how things can become other things, right? How rocks can become other rocks. So anything can become a sedimentary rock. It just has to become sediment first, right? So it has to undergo weathering and erosion to become sediment, right? Which is dirt. And then as long as it gets some pressure and compacted and cemented together, it becomes sedimentary rock, right? Any rock can become metamorphic rock as long as it undergoes some heat and pressure, and it's metamorphic rock. Doesn't totally melt, right? But undergoes some heat. And then anything can become igneous rock as long as it gets totally melted into magma or lava. It has to go through this step first, and then it cools, which is also called crystallization, to become igneous rock. Here's another view of it, right? Again, sediments can become sedimentary, right? Anything can become sedimentary as long as it undergoes weathering and erosion, right? The green arrows here are weathering and erosion. And sedimentary rock can become sediments again and then become sedimentary rock again, right? Notice metamorphic rock has these like yellowish, green, olive colored arrows. Heat and pressure, right? Any rock can undergo heat and pressure, become metamorphic. Magma, right? As long as it melts, then it can become igneous rock. I can even add an arrow here from sedimentary and draw it to magma. That can also become magma, right? And then cool and become igneous rock. Okay. So those are my orange arrows, the melting ones, right? And then it has to cool to become igneous rock. So here are some examples. Obsidian is a really good example of an igneous rock. I have lots of examples in class. I also have a separate video about rocks that you can watch that kind of shows you a little bit more information about this. Then sedimentary rocks, remember I said that it's like really easy to see the layers in sedimentary rock, so that those are pretty easy to identify. This is what we're going to have here in Eagle Pass. This is what naturally occurs here. We bring in rocks, right? If you notice in the math building parking lot has these like pink rocks. Those are granite, and that's an igneous rock. So those were brought in from somewhere else, probably around the Austin area. The Capitol building is actually made out of granite. It's like a pink granite, which is an igneous rock. And so there's a lot of igneous rock in that area north of Austin. But here in Eagle Pass, naturally, we're only going to have sedimentary rock. We don't have any volcanic activity. The closest you could go to find some volcanic rock is probably like the Uvalde area. They have some extinct volcanoes there. So metamorphic rock is probably the most difficult to find because you have to have those special conditions where it gets heated and kind of melded together. See how these are like, you can see layers, but they look melded together. So there was heat enough to meld them together, but not enough heat to melt it, right? So it's kind of like that happy medium right there where it gets heated but not melted. And so these are a little bit more difficult to find. But here's some examples here, and I have more examples in class to show you. Okay, so let's review really quick physical and chemical changes, right? And physical and chemical weathering, okay? So all types of weathering, right? They're both types of weathering, right? They can occur anywhere and they change the rock in some way. Physical weathering is going to be a physical change. So really it's movement here. They're going to break apart without changing their chemical composition. So this would be like, a rock in a river getting worn away to become really smooth. That's physical weathering, right? Chemical weathering is going to be actually a reaction, right? Just like a chemical change. They're changing the chemical composition of rocks by a chemical reaction. This would be like rusting. Red rocks are going to have iron in them, and the iron is oxidizing. That's why it looks red, because it's rusty. So physical weathering, right, breaks down rocks. Factors include wind, water, sun, ice, temperature change. All of these things can physically break down rocks. And then for chemical, rocks are chemically altered, like hydrolysis, oxidation, right, the rusting I was talking about, acid, like in cave formations, you'll have chemical breakdown, basically the dissolving of the rock. Acid rain can also do this. Anything acidic will also break down rock. Okay, that's all for the rock cycle. Please let me know if you have any questions, and thank you for watching.